Every glance upward is a leap backward in time. The shine of distant suns and nebulae began their journey through the universe ages ago. By the time their rays brush Earth, civilizations may have risen and fallen in their own star systems. These cosmic messengers, traveling for millennia or more, offer us a window into stellar history. But something always stands in our way. We peer through deep oceans of cosmic dust, swirling veils that block and absorb visible starlight. And as the universe expands, those ancient beams of light are pulled so far into the infrared that normal telescopes can't even find them.
It's as if nature itself guards the greatest secrets at the edge of our sight, daring us to invent new tools to glimpse what lies beyond. Throughout history, our vision was shaped by these barriers. The mystery of how galaxies form, when stars ignite, and what cosmic epochs looked like just after the Big Bang remained hidden. Yet, it's not just science at stake. Humanity's oldest myths and legends are interwoven with awe for what lies beyond the clouds. Ancient astronomers tracked wandering planets, built monoliths and pyramids aligned to solstices and stars, always searching for meaning in the distances. Today, we continue that quest with technology our ancestors could barely imagine: satellites, rovers, and now the most advanced eye ever turned to the heavens.
The secrets began to unravel on a day that will echo in scientific history. December 25th, 2021. The James Webb Space Telescope, after decades of design and countless challenges, finally took flight. Think about that. A collaborative effort spanning 3 major space agencies, thousands of scientists and engineers, billions of dollars, and innumerable late nights. What they unleashed was more than a telescope. Webb is a cosmic archaeologist, carefully peeling away the veils of space-time itself. Its suite of precision infrared sensors can stare through even the densest star-forming regions and touch light emitted in the earliest days of our universe. The impact was immediate. Suddenly, regions that appeared blank or opaque in previous observations lit up with activity. Cold, dark clouds now teemed with young suns. Ancient galaxies, invisible before, were revealed in crisp, ghostly details. Webb doesn't just look, it listens, measuring faint heat signatures, odd chemical fingerprints, and vibrations from galaxies millions of light years away.
Already, Webb has reset the boundaries of astronomy. In less than 4 years, it has completed hundreds of research programs and harvested more data than Hubble gathered thought we understood. One of the first things Webb's golden eye showed us were details within our own solar system that no previous telescope could see. Jupiter's swirling auroras, ring patterns never before resolved, and shifting cloud bands, all glowing in the crisp sensitivity of the mid-infrared. But Webb's gaze doesn't stop at the familiar. Each week brings new surprises, unprecedented flares from dying red giants, star clusters with strange chemical signatures, wandering objects visiting from interstellar space, and the ghostly remnants of stars that exploded long before the first humans walked the Earth. Let's start our cosmic tour close to home. Neptune's usual blue shimmer all but disappears in Webb's images. What's revealed instead are dark, almost invisible zones set against glowing rings and ghostly clouds. These clouds, faint, barely reflective at visible wavelengths, light up when seen in the infrared, exposing the structure of Neptune's upper atmosphere and delicate arcs of its rings. Webb made visible features that had eluded astronomers for lifetimes, including newly discovered moons and wisps of methane snow. But Webb's reach stretches far past Neptune. On August 6, 2025, it joined the hunt for something truly extraordinary: Comet 3I/Atlas. Unlike any local comet, Atlas carries the chemical fingerprints of another solar system.
Webb's sensitive spectrograph picked out unusually high CO2 and water vapor, evidence that this frozen traveler was born in another star's ancient disk. But what startled scientists most was its ratios. Atlas contained a cocktail of chemicals rarely seen together, raising fresh questions about how planetary systems assemble and whether the seeds of life might travel on such cosmic messengers.
More than just capturing solar system oddities, Webb's largest impact may be its exoplanet discoveries. Before, thousands of planets were known, but details were scarce. Now, Webb's infrared instruments can block overwhelming starlight, acting like a cosmic sunshade, and reveal the faintest planetary signals around even tightly packed binary stars, like those in the Alpha Centauri system. Webb recently identified what appears to be a gas giant with a path sweeping through that star's habitable zone, a zone where, just maybe, moons or even rocky planets with the right chemistry might one day be found. While gazing outside our system, Webb also tears back the dusty curtains around cosmic nurseries. The iconic pillars of creation, famous from Hubble's images, are transformed. Where once we saw only dark columns, Webb's view reveals legions of newborn stars, bright red beacons still swaddled in gas and dust. These hotbeds of activity pulse with energy, shockwaves, plasma jets, and clustered baby stars, challenging old theories of how such regions evolve over time. More than just capturing solar system oddities, Webb's largest impact may be its exoplanet discoveries. Before, thousands of planets were known, but details were scarce. Now, Webb's infrared instruments can block overwhelming starlight, acting like a cosmic sunshade, and reveal the faintest planetary signals around even tightly packed binary stars, like those in the Alpha Centauri system. Webb recently identified what appears to be a gas giant with a path sweeping through that star's habitable zone, a zone where, just maybe, moons or even rocky planets with the right chemistry might one day be found. While gazing outside our system, Webb also tears back the dusty curtains around cosmic nurseries. The iconic pillars of creation, famous from Hubble's images, are transformed. Where once we saw only dark columns, Webb's view reveals legions of newborn stars, bright red beacons still swaddled in gas and dust. These hotbeds of activity pulse with energy, shockwaves, plasma jets, and clustered baby stars, challenging old theories of how such regions evolve over time.
The telescope's distant lens also captures breathtaking galactic tapestries. NGC 628, the Phantom Galaxy, appears with waving red and orange ribbons, glowing clouds of gas tracing out vast spiral arms. Webb has shown how ancient stars cluster in blue, younger stars light up in pink, and dust-rich bubbles, blown out by supernovae, dot the arms. The survey of 19 massive spiral galaxies lets astronomers see exactly how new raw material for planets and life is produced, distributed, and recycled. But that's not all. Webb allows scientists to see into the farthest, faintest reaches of the universe. Gravitational lensing, a massive galaxy cluster warping the very fabric of space, magnifies the ghost signals from galaxies that lived and died billions of years ago. In 2023, Webb did the impossible, capturing a supernova that exploded in a galaxy far behind the cluster. With its light split into several images, multiple echoes of the same ancient event. By measuring the difference in their arrival times, astronomers, like cosmic detectives, can refine our understanding of cosmic distances and the speed of the universe's expansion.
Now, Webb is pushing to the very edge of existence, nearly to the beginning of time. Its instruments, trained on the faintest glimmers, have confirmed the existence of galaxies like GSZ 140, shining just 300 million years after the Big Bang. Yet, what they saw was baffling. Galaxies larger and more developed than any theory predicted for that dawn era, hinting at a turbocharged universe or new physics.
one radical idea has returned to the conversation. Perhaps the first dark stars were powered by dark matter, not fusion, growing unfathomably bright and massive, and seeding the universe with the ingredients for everything to come. Each Webb observation is a revelation and a challenge. The universe, seen through its golden mirror, is at once forever older, younger, richer, and wilder than we dared imagine.